Okay, today we're going to talk about direct variation. A definition for direct variation is when y varies directly as x, it means that y equals k times x, where we say k is the constant of variation, also known as the constant of proportionality. This can also be written as k equals y over x. This should look a little bit familiar just because we have dealt with linear functions, y equals mx plus b. And this should kind of remind you of that. The k is like our slope, all right, but it's a little different as well. So we're going to look at some of the differences. Let's say, for example, that we have y equals x. Here, our k is 1, and we call this the constant of proportionality. When we look at the table, we see this constant of proportionality by taking our y and dividing it by our x. For instance, 1 divided by 1, it gives us 1, which is our k, right? Right here, it's our k. Even though we don't write it, there's a 1. In a graph, we see it as a graph that goes directly through the origin. All right, it goes directly through the origin. And these are characteristics of all direct variation problems. All right, it's not a characteristic of all linear functions, but it is a characteristic of all direct variation problems. All right, so let's look at this table here. All right, we have some examples of direct variation. We have -4, -1, -16, -4, -40, -10. Can you find the constant of variation? Remember, in order to find the constant of variation, we have to do y divided by x. In this situation, we could take our -4, -1, or -40. -10 divided by -40. So this is -1 divided by -4, or -10 divided by -40. It shouldn't matter which ones you choose because either way, it's going to simplify to 1 over 4. So our constant of proportionality here is 1 over 4. If we wanted to write an equation and take it a step further, then it would be y equals 1 over 4 x. That is the equation for this problem. How do I know that? Because we said at the top that direct variation is written in y equals k times x form. All right, let's go to our second example here. All right, we're going to our second example. What's the constant of proportionality? Feel free to pause the video and find it out based off of the problem we just did here. All right, to find the constant of proportionality, remember, or constant of variation, we take k equals y divided by x. So that's 30 divided by 10, which is 3. And our constant of proportionality, or our constant of variation, is 3. So for this third one here, it says tell whether each equation represents a direct variation. If so, determine the constant of variation. All right, part A. What do you say? Yep, this is direct variation because it's written in our form y equals k times x. All right, remember, y equals k times x. And our k in this situation is 6. What about B? No. because it's not written in the form y equals k times x. All right, think about C. All right, this is going to need a little bit of manipulation. So if we add 15x to each side, we kind of end up with 5y equals 15x, right? And then if we divide each side by 5, then we have y equals 3x. And now this looks a little bit more like y equals k times x. So here our answer is actually yes. And our constant of variation is 3. All right, now remember that the graph of a direct variation will always go through the origin. For instance, like this example here. All right, so let's look at some graphs. And we're going to tell whether or not they're direct variation or not. And we're just going to go through and write yes, no, yes, no. All right, looking at this example, this graph does not go through the origin, so it's a no. Second example, this graph does go through the origin, so it's a yes. Feel free to pause the video and go through the rest of them. All right, this is a no, a yes, no, no, yes, no. All right, so we know graphically what direct variation looks like. An equation, we know what it looks like, and in a table, we know what it looks like. All right, so how do we use direct variation to find unknowns? All right, the steps we take is to first find the constant of variation given a word problem. And then we use our y equals kx to find the unknown. For example, Julio's wages varies directly as the number of hours that he works. All right, first off, this may sound a little funny, but remember when we first started talking about direct variation, we said direct varies directly. All right, if his wages varies directly as the number of hours, that means that if his wages go up, if the number of hours goes up, then his wages go up. And if his hours go down, then his wages go down, which makes sense. The more you work, the more you make. All right, so we need to keep this in mind, right? This is money and this is hours. And we said the first thing we want to do is to find the constant of proportionality. Well, let's finish reading. It says if his wages for 5 hours are $29.75, how much will they be for 30 hours? Well, first we have to deal with the 5 hours. He makes $29.75. And we need to determine our x and our y. Notice when I first started talking, I was going to say that the wages were dependent upon the hours, or the hours were dependent upon the wages, but that's not true. All right, it's a certain way we have to say it. Note that the dependent variable is our wages, because how much he makes is dependent upon the number of hours. So our hours is x and the wages is y. So when we find our constant, we have to take his wages, just $29.75, and divide it by x, number of hours, which is 5. All right, now we need a calculator. And so we take 29.75 divided by 5. And the constant of variation is 5.95. Just means how much he makes an hour. All right. So now that we know our K, we can actually put this into our formula, y equals kx. And it would be y equals 5.95x. So the second step here is to use y equals kx to find the unknown. All right. All right. So it says, how much will they be for 30 hours? Right? How much will his wages be for 30 hours? Well, we simply plug and chug here. Y equals 5.95 times the number of hours, which is 30, because X is hours. All right. And let's figure this thing out. Plug it in a calculator. And he makes $178.50. All right, and we found the answer here. We found the one we want, at least. All right. So in the next example, it says a local restaurant earns $9,000 in a 4-hour period. The total amount of earnings varies directly with the number of hours. Now, y is going to always vary directly with x. That means that the earnings is y, right? This is y. Varies directly with the number of hours, which is x. All right. Says find the total earnings if the restaurant is open for 9 hours. Well, we were given a little bit of information in this first sentence that in 4 hours, $9,000 were made. So to find our constant of variation, which is the first step, we take our y, which is earnings, and divide it by our hours. So 9,000 divided by 4. So that's 2,250. All right. So that gives us y equals 2,250x. That's how much he makes per hour. So find the total earnings if the restaurant is open for 9 hours. Well, this is a matter of plugging and chugging, which just means we substitute 9 and then simplify. All right. And in 9 hours, it's $20,250 here. All right. There's our answer. Last one. Weight varies directly with the planet's gravity. That means weight is our y, planet's gravity is our x. A Mars rover plus lander weighs 767 pounds on Earth, but only 291 pounds on Mars. The Mars rover without the lander weighs 155 pounds on Mars. How much does the rover without the lander weigh on Earth? Well, the whole weigh on Earth is y, right? And the planet's weight, or gravity, we say, is x. All right, so our first step is that we're going to determine our constant of variation by taking our y, weight on Earth, and dividing it by our x, which is the planet's gravity. We're given that the weight on Earth is 767 and on the planet is 291. All right, we just need to use our calculator here for a second. And we have approximately 2.64 is our constant. All right, that gives us an equation of y equals 2.64x. All right, and when it says that the Mars rover without the lander weighs 155 pounds on Mars, how much does the rover without the lander weigh on Earth? That means we're going to have to substitute for x, 155. So this is y equals 2.64 times 155. which is 409.2 pounds on Earth. We'll just say 409. And we're done. Now make sure you complete the check for learning.